Okay, so now let's look at the preview of calculus. We will talk about what we will learn from the calculus 1. There are two major problems we will discuss in the calculus 1. The first one, if you have an arbitrary curve in the xy plane, and we know the point on the curve, right? And then we want to find the tangent line of this curve. Okay, so this is the one problem which is called the tangent line. So in order to find the equation for a tangent line, the tangent line is a straight line. So if we know this point, and we need to find the slope, right? The slope, this is the very important thing, the slope, which is denoted by m. Okay, if we know the point, if this point is given by, this is the a, so this is the f of a, of the f values of this point, this is the y equals f of x, right? So if we know the slope, then we can use the point slope form, which is y minus f of a equals the slope times the x minus a. Right? This is the slope point form. Okay, so but it's very hard to find the slope of this tangent line. So the idea is, let's pick arbitrary point on the curve, except this black point, we draw a second line which we connect these 2 points, right? Then we have a straight line. And if we know 2 points, right, we can always find the slope of this straight line. Then we can pick arbitrary point to get the equation for this straight line, right? So we have the equation, we can find, if we know these 2 points, and then we can find the equation for the blue line. But if we move this point towards the black point to here, right? Then we connect the black point and this yellow point, you will have another one, which is the yellow line. Then we can also find the same thing. If we know 2 points, we can find the equation for this yellow line, right? As the point moving towards to the black line, like this way, okay? We use another color. Moving along the curve in this direction, then you can imagine the second line, which is the blue line or the yellow line, will approach our black line, right? So this is the idea to find the slope of this black tangent line. So we use a limit, which is called the limit, right, to discuss this problem. So this is the first problem. The second problem is, if we have a curve which is between x and y, between x-axis, right? A curve which is above x-axis, and we want to find if this is the a, from A to B, and we want to find the area for this shaded region, right? The shaded region. So how to find it? So the first thing, we want to look at some ideas. We divide this interval AB into several parts, into some subintervals, small parts interval. On each interval, you form a rectangle, right? You form a rectangle on each interval. Right? I don't write the other rectangles. So you can add them up to get approximation, right? But this is just approximation. How to get the exact area? So the idea is, let's divide this interval from A to B into very tiny subintervals. Okay? So if we suppose, so in other words, we have AB, right? This is the curve we have. This is from A to B. If the interval is very tiny, you see, each interval we form a rectangle. If it's tiny enough, then the rectangle looks like a straight line. If you add these straight lines up, it would be the exact area, right? So how to make the intervals very tiny? We just let the number of the intervals. How many intervals have we? If we have n intervals from A to B, n subintervals, we let this n approach infinity. We use this symbol. This is the horizontal 8. We use this symbol to denote infinity. That means n is very large. Okay? Then, if the number of the interval is very large, then on each interval is very tiny, right? So the rectangle on each interval is almost a straight line. So both cases, so here we let the point on the curve approach this black point, right? Here we let the n, the number of the subintervals, approaches infinity. So both cases use a knowledge which is called the limit. Okay, so next we will talk about how to find. So we start from the limit as our first topic in the calculus.